Hello everyone, welcome to recitation 3. Today I'm going to discuss about some practice problems from chapter 3. So let's get started. First I'm going to discuss problem 3.18. So here it's given that a rotor of a turbine has 13.6 kg mass and it's supported at the midspan of a shaft with bearings 0.4064 meter apart. Also, the rotor has an mass and a rotating unbalance of 0.2879 kg centimeter. So we have to determine the forces exerted on the bearings at a speed of 6,000 rpm if the diameter of the steel shaft is 2.54 centimeter. And in second part, we have to do the same thing, just the diameter of the shaft will be changed to 1.905 centimeter. Also, here we're going to assume that shaft is simply supported at the bearings. So let's start. First, case 1, where the diameter of the shaft is 2.54 centimeter. So we know natural frequency is 1 by twice pi root over K by M, where K is equal to 48 IL cube, where E is the modulus of stiffness for steel and I is moment of inertia. And we can find I as pi by 64 d to the power 4, where d is the diameter of the shaft, and effective mass of the system would be M rotor plus 0.486 M shaft. Okay, so first calculate I by 64 d to the power 4. So the value is 2.5 and we will get 2.043 to the power minus 8 meter to the power 4. So our effective stiffness K would be 48 IL cube. 48. We are using this modulus of stiffness E as for steel 210 to the power 4 is 2.043 10 to the power minus 8, and L was given as 0.4064 here, where you can see that the mass is supported at the midspan of a shaft with bearings 0.4064 meter apart. So that's our L. Now we will get the value of K as 2.922 to the power 6 Newton meter. So let's just find M of shaft, which is density multiplied by volume. So also we can read the volume as pi by 4 d square L. So the total mass of the system is M rotor plus 0.486 M shaft, or M rotor 0.486 rho pi by 4 mass of rotor was 13.6 plus 0.486. The density of steel we will use as 7830. I will have pi by 4, 0.0254 whole square, and L is 0.4064. So our value of M is 14.38 kg. So now we can calculate the natural frequency Fn, which is 1 by twice pi root over K by M. Twice pi. We got K 2.922 10 to the power 6 and M 14.38. So I got the value of natural frequency as 71.74 Hz. Now if I express this to RPM, I get 4304 RPM, which is our omega n, right? So now we can say omega by omega n. Omega was given at 6000 and omega n we found to be 4304. So the ratio is 1.394. Now the force is equal to, we know, M R plus eccentricity multiplied by omega square. So we need to find both the eccentricity and the deflection R. So in the question it was given as ME was equal to 0.2874 kg centimeter. So E would be 0.2874 14.38. So the value of E is 0.02211 centimeter. Again, we know the deflection R can be E omega by omega n whole square 1 minus omega by omega n whole square. So if I put the value, E is 0.0211 centimeter. Omega by omega n is 1.394 minus 1.394 whole square. So R is equal to 0.04316 centimeter. So we can write F M R plus E omega square. So and omega was 6000 RPM. So if I convert it to radian per second, it would be 2. Just calculate. It would be 628.32 radian per second. Okay, so now I'm just going to put all the values, which is 14.38. R is equal to minus 0.04316 plus E, which is 0.02117 multiplied by omega square 628.32 square, and we got our final answer as 1273 Newton. Now for case 2, we will just do the same procedure, but the diameter of the shaft will be just different. So it's going to be just the same calculation. So this is case 2, where d is equal to 1.905 centimeter, right? So our I would be pi by 64 d to the power 4, or pi by 64, 1.905 10 to the power minus 2, and the value would be 0.64 10 to the power minus 8 meter to the power 4, and k would be 48. The value of E is 210 to the power 4, and I is 0.6464 10 to the power 8, and L will be same, 0.4064 whole cube. So K is 0.9441 10 to the power 6 Newton meter. Similarly for M shaft, M disc is 13.6, 0.486, rho is 7830, multiplied by pi by 4. D would be 0.0195 whole square, or 0.4064. So we'll get the M as 14.04 kg. So Fn would be 1 by twice pi root over K is 0.441 into 10 to the power 6, and M is 14.04. So our Fn is 41.27 Hertz. So now if I express it into RPM, or omega n, I'll get 2476 RPM. So our omega by omega n is 602476 equals to 2.432. Now we need to find the R, which is just find it 0. So here's a correction. Here, when I was calculating ME, it will be the rotor of mass of rotor, so it would be 13.6. Sorry for that. So since the rotor of the mass remains same, the E would be same as part 1, which is 0.02117 centimeter. So now we're going to find the R, which is E omega by omega 1 minus omega n whole square, which write as 0.0217 2.4023 whole square 1 minus 2.423 whole square minus 0.0252. So now we are going to find the set f, which is m r plus e omega square. Just to make it clear again, the me, which was given as 0.2879 kg centimeter. Here m is the mass of rotor. So we have to divide the 0.2879 kg centimeter by the only the mass of rotor, not the mass of whole system, and we will get the eccentricity, just to make it clear. So, and m is the mass of whole system. So m is equal to, as we got it, 0.42. R is minus 0.02552. E is 0.02117, and omega square is 620. Got it? Where it is 628.32 whole square. So F is equal to 241.1 Newton. So that was it. Next, I will move to problem 3.45. So in this problem, it is said that a vibration pickup has a sensitivity of 40 millivolt per centimeter per square from frequency range to 10 to 2000 Hz, and if 1g acceleration, which means 9.81 meter per second square acceleration, is maintained over this frequency range, what will be the output voltage at 10 Hz and 2000 Hz? Okay, let's start. So let me write. So the given is sensitivity, which is 40 millivolt divided by centimeter. Second, we can write the 1g acceleration as 9.81 meter per second square, or I'm just going to do it in centimeter because all other values are given in centimeters. So 981 centimeter per square. Now we know displacement y is y sine omega t. So the velocity y naught is y omega sine omega t, and acceleration would be minus y omega square. Sorry, it would be y omega cos omega t. So as we're differentiating it, and the acceleration would be minus y omega square sine omega t. So if we just take the amplitude, then velocity is y omega and acceleration is y omega square. Now here we're given as, at first we need to find the output voltage at 10 Hz. So let's say 10 Hz, F is equal to 10 cycle per second or 10 Hz. So we know omega is equal to 2 pi f. So 2 pi 10 will give us 62.83 radian per second. Now we see acceleration is equal to y omega square, or we can write it as y omega to omega, which is acceleration is equal to velocity multiplied by omega. So velocity would be acceleration divided by omega. And here our acceleration is 981 and our omega is 62.83 radian per second. So our velocity is 15.61 centimeter per square. Now the output voltage is sensitivity multiplied by velocity. So our sensitivity is 40 and velocity is 15.61. So our output voltage would be 624.5 millivolt. Now for part B, we're just going to will be the same procedure, and we're going to find it for 2000 Hz. So let's do it. F equal to 2000 CPS or 2000 Hz. So omega equal to 2 pi 2 multiplied by 2000, and it would be 12566 radian per second. Now the velocity would be acceleration by omega, which is 981 12566, and we'll get the velocity as 0.07806 centimeter per second, and then the output voltage will be equal to sensitivity multiplied by velocity. So sensitivity is 14 and the velocity is 0.07806, which is equal to 3.123 millivolt. That's it. Next, I'm going to move to problem 3.52. So here, for viscous damping, the complex frequency response is given as HR is equal to 1 divided by 1 minus R squared plus I2 zeta R, where R is the ratio of omega and omega n, and zeta is equal to C by C critical. So we have to show that the plot of Hx plus Iy leads to the equation given as x squared plus y divided by 4 zeta square whole square equals to 1 by 4 zeta r whole square. So let's start. So here HR is given as 1 divided by 1 minus r square plus I2 zeta r, and our ultimate goal is to express it in the form of x plus iy. so that we can find the value of x and y. For that, I'm going to multiply it with the conjugate of the denominator, which is 1 minus r square minus I 2 zeta r. Similarly, here will be 1 minus r square plus I 2 zeta r multiplied by 1 minus r square plus minus I 2 zeta r. Okay. In the next, then we will get here 1 minus r square minus I 2 zeta r, and here it would be 1 minus r square whole square minus I 2 zeta r whole square, which can be written as 1 minus r square minus I 2 zeta r in divided by 1 minus r square whole square. We know I square equals to minus 1, so it will be plus 2 zeta r whole square. Now, if we just separate it, the real and the imaginary part, we can write it as 1 minus r square divided by 1 minus r square whole square plus 2 zeta r whole square plus I equals to, minus 2 zeta r 1 minus r square whole square plus 2 zeta r whole square. So here this is our x and this is our y. So now we're just going to equate it with the equation given. We'll put the value of x and y to the left hand side and see if we can get the same value as the right hand side for proving. So our left hand side is given as x squared plus y 1 by 4 zeta r whole square, or if I simplify it, x squared plus y squared 2y divided by 4 zeta r plus 1 by 4 zeta r square. Okay, so we can put the value of x square as 1 minus r square whole square 1 minus r square whole square plus 2 zeta r whole square plus y square is equal to 4 zeta square r square plus 1 minus r square r square 2 zeta r whole square, and in here we had, so here 2 gets cancelled, so we can write it as 1 2 zeta r minus 2 zeta r 1 minus r square whole square plus 2 zeta r whole square, where So now this and we also have another one for zeta r whole square. Now if I calculate it, I can write it as 1 minus r square whole square plus 2 zeta r 1 plus r square whole square. Just make the calculation. And for this we can write now if I simplify this, it will become y 1 plus r square whole square plus 2 zeta r whole square minus 1 plus r square whole square plus 2 zeta r whole square plus 1 by 4 zeta r square. So this cancels, which leaves us with 1 divided by 4 zeta r square, which is our right hand side. So we have proved the the h equal to x plus iy representation can lead us to this equation. So this is all I had for today. Thank you for your patience.